Good evening, everyone who has joined the session. So, welcome to the week 6 of problem solving session on industrial wastewater treatment. The instructor of this subject is Professor Alok Sinha and Professor S.K. Gupta from IIT Dhanbad. My name is Maniatam Prakash and I am from IIT Kanpur. So, this is our schedule. We meet every Tuesday from 6 p.m. to 8 p.m. and the Google Meet for this meeting has been already been shared with you. And the recording of this session is being uploaded on the YouTube channel. So if you have any kind of doubt, you can always go back and check. And recording of the last 5 session are already uploaded. You can always go and check. And in the same manner, the recording of the today session will be also uploaded. So, week 6 is related to treatment and disposal of sludge. So, if you recall the previous session, we somehow treated our wastewater and we saw that either it can be precipitated or it can be either solid particle or dissolved particle or suspended particle either can be settled down or can be precipitated by adding some chemicals, and in that manner we are producing a substance that is known as sludge containing water and solid. It contains the sludge definition. We will look into the sludge definition. So previously in all session we were seeing that somehow we are treating, but we were not looking into the product which were produced after treatment. So in this session, we will be more focusing on those things like what I have to do after the treatment has occurred. Okay, now. So the first thing is that a sludge is produced. So how sludge is what do you call is treated or managed, we will be looking into this session. So a great miss if you have gone through the lecture, you might have seen that there were several treatment there are several process by which sludge are being managed. Okay, now. So there will be a brief recap of 4 to 5 to 10 minutes. So in between this, if you have any kind of doubt, you can ask, and then we will have normal question and answering session. Okay, now we I have around 10 to 15, no, 20 questions, so we'll be discussing it one by one. Before going into the question answer session, let's look into the recap. It's like let's just recap whatever has been discussed in your lecture. So this thing we already know what is the sludge definition: settle solid from physical, chemical, and biological treatment process. We know that in primary treatment, then coagulation tank, and then finally biological treatment. In all these treatment, there is some solid are produced, and that is mixed with water. So combination of water plus solid is known as sludge. It contains 1 to 4%. It might be higher also, but in general, if someone say that in sludge how much solid is there, generally it is 1 to 4%, and rest is water. Okay. Primary sludge, we know that in settling tank, due to natural gravity, particle have their own settling velocity and particle settle down. In chemical sludge, that in case of coagulation or flocculation, we add some kind of coagulant such as alum, iron. We have seen these examples. Then in biological treatment also, we have seen that a sludge is produced, and then humus sludge, that is from I think these two has not been discussed. I don't know whether it has been discussed in these two has been biological treatment. We were not looking into the biological treatment, but this is general, like these all type of sludge is in general type. Okay now, so if someone is going through the wastewater treatment, and if there they are reading about this sludge, then they will be dealing with secondary sludge and humus sludge also. Okay, but in this industrial wastewater, we were mainly focused on primary sludge and chemical sludge. Okay, so if we look into the management, like there is a proper management. What is the proper definition? The sludge management refers to the process of handling, treating, and disposing of the sludge that is generated during the wastewater treatment. Okay, so we have to handle it, treat it, and we have to dispose it, because we know that the sludge solid present in the sludge can be very hazardous, or it's kind of a pollutant also. So we have to treat it before. First we have to handle it so that there is no leakage, or it is not leaching. Once it is being handled properly, then we have to treat it and make sure that if I am disposing those solids or sludge, then it is not causing any kind of pollution to environment. So we have to handle it, treat it, and dispose it. Sludge is a semi-solid byproduct containing organic matter, heavy metal, nutrients, sometimes pathogens. Effective sludge management is crucial for environment sustainability, as untreated sludge can cause pollution, but treated sludge can be beneficially used. Okay now, so why it is known as sustainability? If you have gone through the lecture, you might have heard of anaerobic digester, where they digest the sludge, and only we digest sludge which have high amount of organic matter, then that can be used to produce some kind of biofuel in form of methane. So, and that is like, if you are doing it, then you are producing too much, like you are doing many things, producing electricity, producing some kind of income. But if you have left your sludge in environment, in open area, then it will just contaminate your area, surroundings. Okay now, then these are four treatment process that is used throughout the world. Okay now, first we have to thickening, that is reducing the water content, because see, water can be removed, and we are more concerned about the sludge which is solid which is there. So for that, first we have to thicken the sludge. So there are several processes that you have gone through in the lecture, that how to reduce the water content. Then stabilizing. Then we have to minimize the organic content, reducing odor and pathogens. Okay now. Then there is process of, because we know that if a high amount of organic matter is there, high amount of organic matter is there, then a order can be generated, means like it will be like not a good, it will be a home to many pathogens. So we have to stabilize our sludge also. Then dewatering, further removal. Once we are stabilized, we have treated our organic matter, then we have again, we will be have still we have huge amount of water content, then we have to dewater it. Okay na, and then finally disposal or reuse. Okay na, so sludge may be disposed in the land of, incinerated, or reused in agricultural or construction. So these are some of the examples which has been given in your uh, lecture notes. Okay, na? Just 1 minute. If anyone have any doubt, you can always write in chat box. Uh, these are some of the sludge characteristics, what happened that mm, hmm, water. Hmm, what if we talk about the sludge, then there is a free water around 75%. Remember, we have 96% water which is there, and only 4% solid. Out of these 96, 75% is free water that can be, if you keep it, what will happen that it will a supernatant will produce, and that can be removed. Then we have interstitial water trapped inside, like there will be two particles inside that. Some water will be trapped, so there is some process, like by another process we have to remove. Then we have vicinal water, like it is bound to particles in the dissolved form, like not dissolved form, like it's inside the particle, like how to explain. Mhm. It's it attached, means like there will be particle and water is surrounding those, so we have to remove by some other advanced process. Okay, now then we have water of hydration, that is chemically bonded. The best way to measure is sludge volume index. So we have Imhoff cone like a structure, this V shape structure. Okay, na. So generally, what is happen that if we want to measure how much settlable solid is there in our wastewater in sludge, so we will take 1 liter of that sludge, and we will pour in this glassware that is known as Imhoff cone. So what will happen that after 1 hour, all the solid which is there will settle here, and this is our main sludge. Okay, now so settleable sludge divided by MLSS. MLSS generally is 1 liter. It can vary uh, depending upon the type of wastewater and all this thing. Okay, now so we will be looking some numerical example related to this, like what is this sludge volume index. It's just to represent the characteristics of a sludge. Okay, now so if its value is 50 to 100 milli ml per gram, then we say that it is a good sludge. Good sludge means the water can be easily removed. Okay, now if its value is greater than 200 ml per gram, then we will be see that bulking sludge. Bulking sludge means a high amount of organic matter is there, and the particles are there which is there are not settling. So the treatment of those kind of sludge will be very difficult. So that's why it is known as bulking. And why it is bulking, there means there are several reasons, and one of the reason is too much colloidal particles, or too much bacteria, or too much filaments. These kind of reasons are given. That's why what happened that those particles remain suspended in the water. Okay, so what that's why it is known as bulking sludge. Then one of the final main um, uh, one of the like main, not main, but one of the like rigorously used method for sludge management is anaerobic digestion. Okay, now so what happened that our aim is to like convert those solids into some useful product. So this there are many method to digest our sludge. One of the method is anaerobic digestion. Anaerobic digestion is like digestion in the absence of free oxygen. Okay, so generally there are four process. First is hydrolysis. We know that our organic matter which is present in solid will be in very complex manner. Okay, so the first is that in presence of water it will be broken down into simpler form. Then we have second process is acidogenesis. Okay, na. So see, to convert, to break down this organic matter, a special a anaerobic bacteria is required. So what happened that in our system in our digester we add our sludge, and we also add some kind of bacteria that is specific for this kind of activity, and those bacteria breakdown helps in breakdown of higher means breakdown complex organic matter into simpler form. Suppose here a starch is considered as a starch is a very complex organic matter, and that can be easily broken down in simpler form, that is in glucose. Then second process is acidogenesis, that is formation of acid. So what is happen that fermentative bacteria converts monomer into monomers is our glucose and all this thing into volatile fatty acid, alcohol, CO2, H2O. Major products are butyric acid, proponic acid, and lactic acid. Okay, now just don't go through this, but just simple remember that first is will be hydrolysis, then acidogenesis. Third is then acetone genesis. See, here we are producing acid, and here we are producing acetone. Yeah, some acetone products. Okay, now. So now here what happened that we have acids, that is some kind of volatile fatty acid. So what will happen that volatile fatty acid will be converted into acetic acid, hydrogen, and CO2. Okay, this step is crucial at methogens and only use acetate H2O. So there is some kind of methogenesis bacteria required for anaerobic digester, and that bacteria only act on acetate. Okay, now so one acetate is produced, so final product will be methanogenesis. So methanogenic bacteria convert acetic acid, CO2 and hydrogen into methane. So you can see the reaction here, we are converting into methane, and this oxygen is also combining with the hydrogen produced here to produce more methane. So finally we have organic matter which was of no use, but with the help of this anaerobic digestion we have converted into methane, and this methane is known as biofuel because it can be burned to produce energy. Okay, so this was all about some recap, what is sludge, what are different sludge characteristics, and out of there are many topics which are very important, but one major topic is this anaerobic digestion. So till now, if anyone have any kind of doubt, you can ask, or we will be going into question and answer. Anyone any doubt? Okay, no doubt. Then, uh, oh, previous assignment. Yeah, okay. You can just give me 1 minute. If just 1 minute. Okay, so tell me about previous assignment. Assignment 5 year 4. You can unmute yourself. You can speak on mic. Okay, na. Assignment 4 or 5. Okay, just let me open the. Just let me open the assignment. Wait for 1 minute. Okay, so if you are saying, oh, they have given the answer as A, I miss answer will be D, electrical double layer. Okay, so I will write a. Okay, the answer given is incorrect. I think answer correct answer will be D. Question number 9. D. Any more? Okay, I miss. Just I will confirm once. Miss, as far as I know, a stern layer is a part of electrical double layer. Okay, now. So when potential is applied, or when electrical current is applied, this whole this there is two part external layer and there is another part, both of them move. Okay now, so the correct answer will be D, electrical double layer. Okay, so I will I will mail to the team so that they can correct it. And regarding your two other problem, regarding assignment 3 and 4 or whatever, I have already mailed them. And you might have received the correction for assignment 1. Few days ago, I also got notification from the NPTEL team that that has been corrected, and this time also I have mailed to them. But let's hope that it is. I have already mailed question number 5. What is question number 5? Huh. This one is the correct. What is the problem in question number 5? 3 mole is reacting divided by molecular weight into molecular. No, for our question it was 20 milligram per liter. Go and check. Let me show you. For our assignment, the question was related to 20 milligram per liter. That's why it was D 9, and you can check it. I am showing you the question number. You can see 20 milligram per liter. For our question, it is 20 milligram per liter, but here in your assignment, it is 10 milligram per liter. I don't think you should have read the question correctly. 10 milligram per liter. Correct. These are correct answer. For 20, it was 9 and 4.68. Big 5. See, 9 and 4.68. As concentration has been halved, so your answer will be also half. That is 4.5 and 2.34. Any another uh, this is its answer will be D. I will mail them once again. Don't worry about that. Apart from these two, any other doubt? No. Okay, so it takes little time for it will take some time for the assignment to get corrected. So just wait for few, maybe 1 or 2 week, but at the end of the day you will get your deserving marks. Okay, so coming back to week number 6, just I request everyone to please participate in the questioning answer. Assignment 3, question 4 and 5. For that I have already mailed 4 and 5. I have already mailed them. Just wait for some time. See, you can see here I have already mailed request for a second. Re-evaluation of assignment 3 and 4. You can see assignment 3, question number 4. Whatever problem you have said, I have already. Question number 5, despite correct the answer, I have already mailed them. Just wait for some time. It will take some time for final resolution, but just wait for some time. At before ending of this session, I will make sure that you all got your deserving marks. Just have patience, little bit. Okay, coming to this session, I have some questions. These questions are also related to question which you might you have got in your assignment 6. So if you have already solved it, good. If not, then just go. Let's see the lectures. See this problem solving section, and if you have any doubt, you can ask. So in chat box, you can write down the answers. This is the first question. What is the percentage of carbon dioxide produced during anaerobic digestion? C. Yeah, this is correct answer. These are very simple questions. Okay, now anaerobic digestion is a biological process where organic matter is broken down by microorganism in absence of oxygen. See, here it is written absence of oxygen means like somewhere now you will find this definition as incorrect. In absence of free oxygen written. See, both like its definition is like this thing anaerobic. When we talk about aerobic and anaerobic, aerobic is in presence of free oxygen, in anaerobic means in absence of free oxygen. When a microorganism is consuming something uh, means digesting something in presence of O2, pure O2, then that condition is known as aerobic. But when a bacteria or any microorganism is consuming some oxygen which is not free in nature, then that is known as anaerobic digestion. Okay, now so just remember that this definition in a very good way. Like don't say that in presence of oxygen, in absence of oxygen. No, both process occurs in presence of oxygen only, but one is happening in presence of oxygen, one is happening in presence of free oxygen, or one is happening in presence of in absence of free oxygen. Biogas methane, in anaerobic digestion, methane is 55 to 70%, carbon dioxide is 30 to 4%. uh, hi, um, a trace amount of hydrogen sulfide and ammonia is also produced. Okay, now so the C was correct answer. This is question number 2. Which of the following process require minimum digestion period? We have two condition: mesophilic condition and thermophilic condition. These are all condition depending upon the temperature where different microorganisms are present, like acts. Certain bacteria acts under certain temperature, that is known as another condition. Certain bacteria acts at another condition, another temperature. Anyone? Okay, B. We have got one answer B. Yes, correct answer is B. See, this is all about temperature. Anaerobic digestion can occur under different temperature conditions. Correct answer is B. We have said it correctly. First is mesophilic digestion. When digestion is occurring around 30 to 40%, sorry, 40 not 40 degrees Celsius. This is the most common digestion process because it is more stable and energy efficient. How it is more stable and energy efficient. For that you have to go and look into the video lecture. There in the lecture you will see the explanation has been given. However, it requires a longer digestion period, typically 20 to 30 days. Thermophilic digestion is around 50 to 60%. This process operates at higher temperature, leading to faster microbial activity and a shorter digestion period, typically 5 to 15 days. It also results in better pathogen reduction and higher gas production, but it requires more energy for heating. So, and remember, in both conditions, different kind of bacteria acts, because we know that certain bacteria can survive at this temperature, certain bacteria will survive at this temperature. Okay, na? So in overall this is a faster process, this is a slow process. So that's why the correct answer was B, minimum digestion period, that is under thermophilic. Also by temperature you can see that more is the temperature, more will be microbial activity. This thing we also look into our day to day life. Okay, na, more temperature, more bacterial activity. That's why you might have heard that mm, whenever there is a water sample or wastewater sample, it is kept at 4 degrees Celsius, because at that temperature microbial activity is also low. Then there is concept of density and all these things, but overall microbial activity is very low at low temperature. Other option are incorrect. Clarification: it is a process used in water and wastewater to remove suspended solid. It is not related to digestion. Oxidation is also not related to digestion. It is a chemical process where organic or inorganic substance react with oxygen. This can occur in anaerobic treatment, but it is not related to anaerobic digestion. So the correct answer was B. Question number 3. For satisfactory working of sludge digestion tank, the pH range. I request everyone to please participate in the question and answering. If you have any doubt, you can always ask. Question number 3. B. Yes. B the correct answer. See, if you have gone through this anaerobic digestion complete process, then there are several bacteria, that is methanogenesis bacteria, then hydrogenesis bacteria, different bacteria. I don't recall the names. All those bacteria acts at neutral temperature, neutral pH range, and neutral pH range is between 6 to 7, 6 to 8. 7 is a circumneutral. I was saying wrongly. Circumneutral means around the neutral pH, that is between around 7. So the best pH range is considered to be as 6 to 8. Okay. For satisfactory operation of sludge digestion tank, the pH of the digested sludge should be maintained within the range of. If your pH range of the sludge is very high, then there are high chances that your bacteria or microorganism which is responsible for the digestion or anaerobic digestion will die, and the your aim won't be fulfilled. Acid forming bacteria works well in lower pH, producing volatile fatty. Methanogen bacteria is responsible for methane formation. Sorry. For methane formation are highly sensitive to pH and works well between 6.5. At below 6 inhibits methane production, leading to process failure. Okay, now. So overall you can see that below 6 your process will fail, because methanogen bacteria will die, and if the pH is also high, then some other kind of bacterial activity will occur and your aim to produce methane won't be fulfilled. So final answer is correct. Correct answer is B, that is between 6 to 8. Question number 4. Which is the first step in sludge treatment process? This thing I have also shown you the on second slide when I was recapping what is sludge treatment. What is the first step in sludge treatment process? What do we do first? A. We have got one answer, that is A. Let's see. The correct answer is A, thickening. That is correct. Sludge water treatment involves several steps to reduce its volume, stabilize the organic matter, and safely disposal or reuse or treat. The first step in the process is thickening, which helps in reduce the water content before further treatment. Okay, now if you recall the all the process, you can see the here we have seen first is thickening, then stabilization, then dewatering, then dispose or reuse. Okay, so this was overall this was the overall process. So the correct answer is thickening. Okay. First step digestion is follow. Digestion is follow thickening and help stabilize the sludge biologically. Then dewatering, further removal of water. Phosphorus. This is the advanced process where phosphorus is recovered from sludge to be used as fertilizer. It is not first step. So the correct answer is A. What is the first stage in anaerobic digestion? What is the first stage in anaerobic digestion of sludge? D. Yes, correct answer is D. The first step in anaerobic digestion is hydrolysis. Hydrolysis. If you recall, there are four processes. That is, first there will be hydrolysis, then acid formation, then acetone formation, then methane formation. Okay, now, but you can see that as acid for hydrolysis is not written, so the correct answer is D. These are the first fourth step. Fourth step. First is hydrolysis. Larger molecule. This thing we have already said. Then acid formation, then acetone formation, and finally methane formation. Okay, so the correct answer is D. None of these. Hmm. What should be the minimum thickness of the sludge to be applied on the sludge drying bed? B. 15 to 30 centimeter. What about others? C. One is saying B, other is saying C. Let's see. The correct answer is B. That is 15 to 30 centimeter. Sludge drying weight is a common method for dewatering sludge by allowing water to drain and evaporate. The thickness of sludge applied is crucial for effective drying, and recommended range is 30 to 50, 15 to 30 centimeter to ensure first efficient dewatering. If the layer is too thin, that is less than 50 centimeter, drying may be faster, but the process become less efficient in handling large volume. Okay, now if the layer is too thick, the water removes slow, increasing the drying time. So that's why it is kept between 15. So these dimension has been found after several hit and trial, and currently at every sludge handling treatment plant, this method is adopted. That is, it should be between 15 to 30 centimeter. Proper drainage and evaporation. Uh, the drainage system below the sludge drying bed must be support percolation. Sludge thickness of 30 to 50 centimeter allow optimal capillary action for moisture removal, and You can see that why other option, someone was saying that A, then you can see that it is lower than lower optimum, lower than the optimum upper limit, which is 30 centimeter. Okay na. So that's why the correct answer is was B, that is 15 to 30 centimeter. That is B. I hope those who were saying C got, you got it, what where you were wrong. We have to maintain a minimum condition, optimum condition, so that we are dewatering our sludge in a most efficient way by not spending too much or not giving too much time, or if, yeah, you can, you got it, Miss. I hope you have got it. The two main gases that evolved from the anaerobic the sludge digestion tank include two main gases. Oh, we have got one answer, C, that is carbon dioxide and methane. C, okay. Hello, is anyone saying anything? Okay. Yes, the correct answer is C, that is carbon dioxide and methane. Methane is around 55 to 70%, and carbon dioxide is around 30 to 40%. Okay, now in aerobic digestion, we already know that methane and carbon dioxide produce, and it is around 55 to 70%, and carbon dioxide is around 30 to 40%. This was your first question also, if you recall it. Other trace gases are also produced, but its concentration is very low. Ammonia and carbon dioxide. Ammonia is minor gas. Similarly, H2S is present, but it is still a minor gas. Ammonia is not a primary gas in biomass. CO2 is the second major gas. So the correct answer was carbon dioxide and methane. Take your time and solve it. I will give you, the current time is 43. I will wait till 45, then reveal the solution. This is very simple question. If you have gone through the lecture, and if you have gone through the lecture, you might have noticed that there are too much numerical question in this session. And if you are preparing for your final examination, then you might expect a lot of question from this topic. Most and the sludge handling questions are very common question. People make mistakes also because it is very simple, that's why. So if you are, whenever means like in wastewater, this problem related to sludge handling is very common throughout. There if you go through the lecture material, you will see lot of numerical question. I have also some numerical question. We will be seeing it. I think does someone want to say something, or whose mic is on? Did anyone solve it? Okay, so let's look into the solution. Solution is very simple. we have one sludge of 500 kg. The solid content is 4%, whose specific is like, we know that when we have sludge, we have two parts. One is water whose density is 1 gram per liter, and then we have solid. Okay na. So generally in your question, what they will give, they will give that around 99 to 96% is water generally, which is seen in domestic, in sludge. Okay na. And the rest percent, that is 1 to 4%, will be your solid. So they are giving, we have one sludge, and we have to find out the volume of that sludge, whose weight is around 500 kg, which contain 4% of solid, and the density of the solid is given, that is 1.1. Okay na. Remember, density of solid is given. If the density of the sludge would we have given, then we could have directly divided by 500 divided by the given density, then we could have find its answer. But as it is density of, then we have to multiply this 4% to this density, and then we have to convert. If you just look into the solution, these are given thing. Weight of the sludge is 500 kg, solid percentage is 4%, and then a specific gravity is 1.1. Okay na. So if we want to calculate the volume of the sludge, then we will be, see, this is not a formula. Okay na. Just don't mug up this formula. Just try to understand it where it is come. So we have to first, we can see that we have to find out the volume of the sludge. Then volume can be, we know that it can be found out uh, with the help of mass and density. We know the mass, but we don't know the density of the sludge. But the density of the sludge can be found out. We know that for our given sludge, 4% is the solid content, and the a specific density of the solid is given. Okay now. I think someone mic is open. I request please turn off your mic. Who, please turn off your mic. I hope you. Hmm. So you can see that we have multiplied, we have keep the weight, we have converted, we have found out the density of the sludge, and then we have divided it. 500 divided by 1000 into 1.1, that by density, and that is the percentage of the solid content. And finally we have volume of sludge, that is 11.36 meter cube. The volume of the sludge is 11.36 meter cube. Any doubt in this question? This thing is also given in your lecture note also. Remember, this is not a formula. Some people mug it up. Then there will be slight variation in the another question. You will get confused, and you, so just don't focus on formula. Just remember two things, that we will have one sludge. It will have solid. Solid will have its own density. Then the sludge will have also water has its own density, that is 1000 kg per meter cube or 1 gram per liter. And this sludge will have another density, and all these density are linked also. A very in detailed way manner in your lecture notes, this thing has been discussed. Okay na. So don't confuse yourself, and there is simple relationship, that is density is equal to mass by volume. This is just simple. Whatever modification you have to do, you have to use a single formula. Just you have to keep in mind that where to use which formula, means where to use which density. In question, it will be specifically needed whether it is the density of solid, whether it is density of sludge. Don't get confused. Solve this question. Determine the specific gravity of total solid of 10% sludge, which has 20% solid as fixed minerals, and have a specific gravity 2.5, and 75% solid or volatile matter with a specific gravity 1. This is directly take like see in your lecture notes, if you solve this question, there is direct formula, but how those formula has been, not, I won't say that is direct formula, they have just derived it with some like interpretation, but how those formula has been achieved, you have to, for that you have to go to the lecture. So similarly for this question, we will be seeing that there is one formula written there, we will putting these values, and we can find out the final answer. But how that term has come, for that you have to go to the video lecture. See, if you go to the video lecture, this thing has been given to, and this thing has been derived also. Okay, na? How this thing has been come. Assuming the weight of the total solid, TS is given 10% of the solid is equal to 1 kg. Hence, the specific gravity of the total solid determine the following equation. How this equation has come? For that, you have to go to your lecture. That is WTS by STS. What is WTS? WTS is where does it go? Ah, just 1 minute. Uh, WTS is the this weight of the total solid. TS means total solid. Okay, weight of the total solid. Then we have WFS. WFS is the weight of the fixed solid. S is the specific gravity of fixed solid. Then WVS is the specific weight of volatile solid. Okay, and similarly, STS is the specific gravity of total solid. A specific gravity of fixed solid. We will be putting all these value, and we have to find the specific gravity of, as we have to find the specific gravity of total solid. Then after putting this value, we can find out that STS is equal to 1.18. So for your reference, I will just show you this where it is written here. Mm, hmm. So you can see that the question has been taken from your this lecture notes only. Only slight variation has been done. Okay, na. So how this thing has been found out, you can go and check in your, see, these are some of the relationship. What is between relationship between total solid and fixed solid? We know that in organic matter, if there is sludge, there is solid, then there will be fixed solid, then there will be volatile solid, and there is a relationship between the specific gravity of solids present in the sludge. So all the things which is there are interchangeable. Okay, so I have used this for our solving our question, we have used this formula. Okay, all the values were given, we have just substituted the value and we have found out the answer. Question number 10. Question number 10. What will be the sludge volume index if 100 ml of sludge is collected in 30 minutes, whose MLSS concentration is 8 milligram per liter? So this is direct formula, MLSS, that is volume of the sludge divided by MLSS percent. Okay, can anyone say what is the full form of MLSS? We will be substituting the value, that is 100 ml divided by 800, as we have to report answer in milliliter per Here. So, remember, SPI is always reported in ml per gram. Okay, na ml per gram means per gram how much ml is there. So that's why we have converted milligram into gram by dividing it by multiplying it by 10 to the power minus 3. So 100 divided by 800 into 10 to the power minus 3, and SPI is 125 ml per gram. Any doubt? Why no one is saying anything? See, these questions are directly from your notebooks. Okay, now I have not made any new questions. Coming to the question number 11, you can see your entire lecture notes is filled with numerical question. I request everyone to go and solve each and every numerical question. This question will be asked in your final examination if you are planning to sit. And I think everyone who is here must be planning to sit for the final examination. So I request you to please go and I request you to please go and solve this question. You can see lots of numerical question, and these numerical questions are really easy. These are not very tough numerical question. Okay, now once you will start doing it, there will be some unit mismatch, not mismatch. You have to just adjust some unit. Just keep in the mind the density, then volume, flow, time period, all these things. Okay, so from these PDF only I have collected some questions and I'm trying to solve it. Okay, now a wastewater treatment plant generates 500 kg of volatile solid per day. The plant operates an anaerobic digester at 35 degrees Celsius, that is mesophilic condition, with 40% volatile solid destruction. Okay, now so whatever volatile solid is there, 40% is being destructed. So we have to find out the methane produced per day and the total energy that can be recovered from the produced methane, considering the methane heat value is 8600 kilocalorie per meter cube. Okay, now so we know that this volatile solid will mostly contain carbon, and this carbon this out of whatever the volatile solids are coming, 40% is being destructed. Okay, now so these must be only way to uh, only way of destruction is to produce these to convert these volatile solid in methane. Okay, now and if you recall the lecture, so what happened that for per kg how much methane is produced, it is universal thing. Okay, now so if you recall the lectures, if you recall the lecture notes, you might know for per kg of volatile solid how much methane are produced. And once you know how much methane is produced, then you can say you already the volume value is given, that per meter cube of methane this much of energy is produced. So you can find out the total energy input output. Does anyone recall how for per kg of how meter cube of methane is produced? Does anyone remember how much methane is produced for per kg of volatile solid? Anyone? Okay, no problem. So remember, for per kg of volatile, 0.35 meter cube of methane is produced. So this is also interesting question. Like if you are, I don't miss, like first it is objective question also, that for per kg. And remember, you don't have to remember. You can derive also. You can like find out how from where this 0.35 come up. Okay, na. So this thing is also written in your lecture notes. Okay, na. There must be what why from where this 0.35 come up. Okay, na. So for that you can see here 0.35 meter cube per kg. Okay, na. So for methane yield is for per kg of for per kg of BOD is a type of a way of representing organic matter. Okay, na. So you can see that for per kg, 0.35 of 0.35 meter cube of methane is being produced. Okay, na. So this was simple question. I was expecting everyone to answer it. Okay, it's no problem. So total methane produced is 200. You can see that only out of this much, 40% is destructed. 40% is around 200 kg per day. So 200 kg into 0.35, 70 meter cube per day. And energy recovered can be 17 to 6. That is this much of kilocalorie per day. So you can see that if you produce this much of methane, this much of energy be produced per day, and this can be used at several places. Question number 12. Please solve it. This much of sludge is being produced, out of which 2% is solid. And what is happening that we are debuttering it, and we see that there is a reduction in reduction in volume. And so you can see that if there is a reduction in volume, then sludge will get thickened, and you have and the solid content will increase. Okay, now remember the I will just say you the I will recap the basic concept. Okay, now so initially we have some solid. It will contain a amount of solid plus b amount of water. Okay, now so after thickening it, what will happen that a will be still a, because solids are not, when we thicken it, solids are not being removed, only water is removed. Our b will get converted into something, say b by b point 0.7 b. Okay, na 0.7 b. So overall volume you can see that has decreased. Initially if the volume was x, then find after removing the water, the volume is 0.8x. Okay, na 0.8x. So initially solid content was a by x. Now the solid content will be a by 0.8x. So overall, after volume reduction, there is an increase in solid content. That this is what is it is saying. Initially it was solid content was 2%. Now the solid concentration is 6%. So we have to find the first we have to find the volume thickened sludge after gravity thickening, and the percentage of reduction in sludge volume. Okay, so just let me remove it. The mass of the solid incoming sludge is mass of the solid flow rate into solid concentration. What is the flow rate? 300 meter cube per day. And what is solid concentration? 2%. That is 2 by 100. So 60 meter cube of solid per day is already added. Okay, now per day. So this much of solid is coming. Okay. Uh, mm, since the total mass of the solid remain the same after thickening, so see what am I saying, that this mass of the solid will remain constant. Okay, now So the volume of the thickened sludge will be mass of the solid divided by final solid concentration. Finally, we have 6 by 100, and mass of the solid will be fixed, that is 60. Then the volume of the thickened sludge will be 1000 meter cube. Okay. So this will be my first answer, and the percentage reduction will be simple. Initial volume by 3000. Final volume is 1000 divided by initial volume, that is 3000 minus 1000 divided by 3000, that is 66.6%. So this much of the volume has been reduced by just removing 200 ml of 2000 meter cube of water. Sorry, not water, means there is overall reduction of 66.67%. And remember, only water is being removed, solid concentration remain, solid amount remain fixed. So this is the main concept behind whenever we solve any numerical question related to this sludge. Then one thing you should keep in your mind, that the concentration of solid will be always fixed, not concentration, that is the mass. Okay, now concentration may vary, but the mass will always be same. Question number 13. I was few minutes ago I was asking the definition of MLSS, the full from, or definition and another thing, full from I was asking, that is mixed liquor suspended solid. So this question is same to the question number 10. I request everyone to please solve it. Not directly related to question number 10. Sorry, it's not related to question number 10. It's entirely different question, but just tell me, are you guys getting or not what I am saying? I am just, I hope whatever I am showing you, you guys, all guys are getting it. If you all guys are not getting, then there is no point of discussion. Again, this question is from your video lecture only, and you can expect this type of question in your assessment, not your weekly assessment. In weekly assessment the question will be simple, but in your final assessment you might, I'm not sure that it will come, but this type of question, because these are directly picked up from your PDF. And when I have seen the trend that most of the question they take from PDF only, and they will give you in your final assessment. The total mass of the suspended solid in the aeration tank and the sludge edge. Okay, now the total mass in the cells is given by the tank volume into MLSS concentration. Tank volume is already given, that is 5,000 meter cube into MLSS concentration. You can see that MLSS concentration is in milligram per liter. So we have to convert into meter cube and all this thing. Okay, now so here you can see that 3,000 has been divided by 1,000. 3000 see, now if you have to convert milligram per liter into kg per meter cube. Okay, now so for that, here we will be multiplying it by 10 to power minus 6, then it will be in kg, and here we have to convert into meter cube, then here we have to multiply it by 10 to power minus 3. Okay, now so this minus 3 minus 6 will be going out, so finally will be it will be equal to 1 by 1000. This 10 to the power minus 3 will come down, so it will be 1000 kg per meter cube. Okay, now did not return, so it will be kg per meter cube. Here I have done, this is 5,000 meter cube, Okay, and here it is 3000 divided by 5000 kg per meter cube. Okay, now meter cube, this meter cube get cancel out, this 1000, this 1000 get cancel out, then we have 15,000 kg. Okay, so the mass of the suspended solid entering the aeration tank will be flow into influent concentration. In question, we have saying that plant receive this much of MLD. MLD means 10 to power minus 10 to power 6 liter per day, with influent concentration of 600 milligram per liter. So again, we have converted into kg. Here you can see that it is milligram per liter. Here it is million liters. So that is 10 to power 6. Here you can see that I have directly written it, but 20 will be as we have to cancel out the this unit na liter and liter, then we have to convert this million mld, that is 10 ki power 6, 10 ki power 6 liter per day, and 20 is already multiplied, 20 into 10 ki power 6 liter per day into suspended solid is 20 milligram per liter. 20 milligram per liter, here we have to convert into here we have to convert into kg, then it will be 200, 200 into 10 ki power minus 6, 10 ki power minus 6, this and this will get cancelled out, sorry, yeah, and here unit was milligram per liter, and this liter will get cancelled out. Finally we will have 20 into 200. You can see that 20 into 200, that is 4000 kg per day. Okay, now the sludge age will be, what is sludge age? Sludge age means whatever the concentration is going, for how much time it will stay, that is sludge age. Okay, now so whatever the mass of the solid is in aeration tank, what is the mass, that is 15 kg per day, and how much is entering, it is entering 4000 kg per day. Okay, now so finally it will be 50,000 divided by 4000, that is 3.75 day. So this is sludge age. This thing has been, what is sludge age, what is MLSS, this has been discussed in detail. This was just a short question from your lecture notes. A more detailed question has been is also given in your lecture notes. I hope this is clear to you. Any more doubt in this question? This question was all related to unit conversion. If you make any mistake in unit conversion, you won't be getting correct answer. Question number 14. This question is related to question number 10. If you are, whatever I have discussed it, if you have understood it, please uh, hmm, please everyone solve it. This is very simple question. Anyone? Okay. So this SVI is given by simple formula that sludge volume divided by MLSS. So 1800, sorry, 18 ml per liter. So and we have converted. We know that we have to report our answer in ml per gram. So we have converted this MLSS, that is milligram per into gram. Okay, na. So that's why 2500, it was at the bottom, so it has gone to the up. So 180 into 1000 divided by 250. SVI is 772 ml per gram. Okay, na. So we know that we have total three type of SVI, three type of sludge. Good sludge that can be settled easily. Then filament growth, due to presence of certain kind of bacteria which is filament in nature, so it won't be settling down in a good way. Then we have bulking sludge, that there is no all the sludge is not getting settled, or there will be too much turbidity or cloudiness due to presence of suspended solid. So that is referred as bulking sludge. So since SBI is 72 ml per gram, the sludge is good and settles well. Any doubt till now? Anyone with any doubt? No, then again we have some objective question. Uh, at least try to solve this thing. Which of the following factor can cause sludge bulking in activated sludge process? Which of the following factor can cause sludge bulking? Anyone? A, B, C, D. Why you guys are not answering? B. We have got one answer. B. Excessive filamentous growth. C. Low organic loading rate. Low organic. We have got two answer. Okay. See, at least any. The correct answer is B. That is excessive filamentous bacterial growth. See, whenever there is a talking about bulking means like too much sludge is there in your system. So that will be only due to something which is growing in excess. And if someone is saying low organic loading rate, then
Yes, 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 sorry.
it's okay, of course. So the sludge bulking occurs when filamentous bacteria outcompete the flocculating bacteria, preventing proper sludge settling. Okay, so this was very simple question. Question number 16. In anaerobic digester, why is maintaining a proper C by N ratio important? If you have gone through the lecture, this point was discussed, that we have to maintain a carbon by nitrogen ratio. B got one answer, that is B. Yes, the correct answer is B, that is to optimize the methane production. Okay, now generally what happens that a ratio of 20 to 30 is to 1, like carbon should be always higher. Okay, now to ensure sufficient microbial activity for efficient digestion and methane generation. Okay, so this is has to do with like we know that bacteria needs carbon as a food source, so it should be in sufficient amount, so that all the bacteria can survive and a proper digestion can occur. Okay. Question number 17. Which of the following is not remember not an advantage of anaerobic sludge digestion over aerobic digestion? You have the question. Remember the question. Not an advantage. Methane, does it produce methane? Yes, it produces a methane, so it is an advantage. So this won't be our answer. Required less operational energy. Similarly, you have to see reduce sludge volume more effectively. And third is provide faster sludge stabilization. Anyone? Anyone with any answer? D. Provide faster D. The anaerobic digestion is faster than aerobic digestion is faster than anaerobic, but anaerobic digestion is more energy efficient and reduce uh, sludge volume more effectively. Okay, na. So this is not an advantage. Uh, this is not an advantage of anaerobic sludge digestion. Okay, na. uh, it can be little bit confusing, but remember when we are talking about stabilize like actually if you recall this anaerobic, then there we have to maintain several things, like we have to maintain pH, then we have to maintain C by N ratio, and there are several things also. Slight deviating and like it is said that the process is, I don't, like, just just read the statement. Aerobic digestion is faster. Okay, na. This is not anaerobic. Aerobic digestion is faster than, but anaerobic digestion, yes, it is more efficient, but if we talk about the fastness, aerobic digestion is more faster. Okay, so the correct answer was D. Question number 18. Why is the pH range of 6.8 to 7.4 is ideal? General, see, this is more robust pH range. Okay, now in general you can say between 6 to 8, but if someone want to be more precise, it can also say that it should be 6.8 to 7.8. Please answer it. B. It promotes maximum methane formation by methanogenesis. Any okay, the correct answer is B. These are very simple question. So remember we were saying about methanogenesis bacteria. So they will only act within a circumneutral pH that is around 7. Okay, now so that's why this methanogenic bacteria thrive in the neutral pH range, that is between 6.8 to 7.4. pH imbalance can cause process failure due to acid accumulation. Question number 19. In sludge treatment, what is the primary function of sludge thickening before digestion? B. To reduce the volume of sludge and increase the solid concentration. Let's see the answer. Yes, the correct answer is B. Whenever we are talking about thickening is removal of water, and if we are removing it water, then uh, uh, we are just reducing the volume of the sludge. Okay, na. So the thickening removes free water, increasing sludge solid concentration before digestion or dewatering, thus reducing overall treatment cost. Okay, so the correct answer was B. Question number 20. Why is seeding with digested sludge beneficial in anaerobic digestion? So if you recall the recall like if we want to for faster, we know that this anaerobic digestion is very slow process, like as compared to aerobic digestion, but somehow we want to enhance the process. So what happened that we uh, what we seed like we seed it with the help of digested sludge. Okay, now so in past we have some sludge which is already digested. So in our reactor we will add those digested sludge. So why it is done? To it increase the solid volume for better mixing, it provide extra cellular enzymes, and so just remember generally what happened that just try to answer it. D, we got one answer. D, increase the pH of sludge to prevent acidification. Anyone with any other answer? So remember what is B, huh? So remember in anaerobic digestion what we are doing it. We are generally what will happen. So suppose this is our this much is initially this much is organic carbon. Okay, na. Remember this bi-axis is representing organic carbon. So in a aerobic digester, this we have this much of carbon and we want to reduce it. Okay, na. So what will happen that if we start from the simple process, so what will happen that first there will be some initial bacteria. So in simple process what will happen that there will be simple bacteria. Okay, so first it will populate, then its number of concentration population of the bacteria will increase, then it will start consuming this carbon. So now imagine a case that where what we are doing that we are adding some bacteria which is required for consumption of this carbon. So what will happen that it will enhance the process. So now what is the best source of bacteria? The waste source will be digested sludge, because digested sludge will contain a lot of bacterial active bacteria that is eager to digest more and more carbon. So what will happen that if we add the digested sludge which contains a lot of active bacteria, and that will start to consume the carbon as soon as we add in the digester. It won't wait for some time to settle down. A number of bacteria will increase, certain number of bacteria will increase, then it will start. So that process can be minimized by adding activated bacteria. So the correct answer is B. So if someone was saying that increases the pH of the sludge, we don't want to increase the pH of our sludge. And by increasing the pH, there is this option was incorrect in itself. Okay, na. So first, the pH range we know that it is circumneutral, and adding the just sludge won't cause any increase or decrease. It will be in neutral range. The main thing you have to see that if there is active bacteria, it will start consuming the carbon as soon as it is added in um, digester. The correct answer is B. It provides extra cellular enzymes and active bacteria to accelerate digestion. I hope you have got it. Those who Those who were saying B, D, D, I hope you have got my answer, my explanation. Moving forward with 21st question. What happen if the solid retention time, that is SRT, in an activated sludge process is too low? Answer it. What happens if the solid retention time in activated sludge? Solid retention time is simply like for how much time the solid is being retained uh, in the digestion process. The correct answer is B. That is microbial population will not have enough time. So we know that if the time like if we want to digest something, then there is a need of some, there is a requirement of minimum time. Now if that time is being reduced, so what will happen that what will happen, the required time won't be sufficient, so not enough digestion will be occurring, okay now. So the microbial population will not have enough time to stabilize, reducing the treatment efficiency. If SRT is low, the beneficial bacteria burst out before they can effectively break down the organism, reducing the treatment efficiency. Question number 22. What is the primary purpose of sludge digestion in wastewater treatment? Just answer it. I'm coming in 1 minute. Okay. So we have got two answers. That is A, to reduce the organic content and stabilize sludge. That is correct answer. Sludge digestion break down the organic matter, making the sludge more stable, less odorless, and easier to handle. Question number 23. In gravity thickener, what happens if the hydraulic retention time is too high? Hydraulic overflow rate, that is HLR, HOR, I don't know, HLR, is too high. So we know that we have gravity thickener to dewater our in sludge handling. We when we are dewatering, so there is this gravity thickener. Okay, na. So now imagine that hydraulic overflow rate is too high. So like hydraulic overflow rate means like a huge amount of water is being passed. Okay, na. So what will happen? So the solid particle may be burst out, reducing the effectiveness of the. Now imagine that too much of water is coming. So what will happen that the like suppose this is our sludge weight and we are passing too much of water. So and our main target is to let the solid settle so that water can be removed. Okay now. So now imagine that if we are passing too much water, so won't be any time for the solid to settle, and it will just washed out, and overall the efficiency will be reduced. Okay, so the correct answer is C. Second last question. I think I have one more. Second last question. 24. Why is methane gas collected from anaerobic considered a renewable source? Read each and every line, every option, and try to answer it. B. We have got one answer. B. Oh, we have got two answer. It continuously produces from organic waste and replaces fossil fuel. Yeah, yes, you are correct. It continuously, yeah, simple. Methane is known as biofuels. It has been used from few years. People are using it, and we are producing in very cost effective way through aerobic digestion. So it is known as renewable energy. Okay, now it is continuously, methane are produced from aerobic digestion is biofuel derived from organic waste, making it sustainable alternative to fossil fuels. Okay, question number 25. It is a numerical question. Take your time. We have lot of time. A wastewater treatment generate a combined sludge flow of itna meter cube with an initial solid concentration of 0.8. Uh, the sludge thickened by 5% using a gravity thickener. The selected solid rate, that is SLR, solid loading rate is 50 kg meter cube per day. So the total mass of sludge entering the thickener per day, the required surface area of the thickener, the diameter of the thickener. Assume the circular design with two units. Okay, na. So for dewatering or thickening, we are using gravity thickener. So here there is this much of sludge is coming, on which 0.8% is solid, and the efficiency is such that the sludge is thickened to 5%. Okay, now initially 0.8% was there, now 5% is solid is there. So remember, which of the which when we are thickening the sludge, what will be the fixed thing? The fixed thing will be solid mass of the solid. Okay now, so if initially x amount of the solid, x kg of the solid is there, finally in the sludge, even though 5% concentration has been achieved, the solid concentration will be x kg only. Okay now, the only reduction will be happening in the water. Okay, then we have solid loading rate. At this rating, this rate, the solid is being loaded in the thickener. So you have to find the total solid entering the thickener per day. Okay now, does anyone want to solve it, or should I reveal the solution? Okay, though the mass of the solids entering the thickener per day, this thing is simple. Flow rate into solid concentration. Again here we have played with the unit. Okay now, this unit is meter cube per day. Okay, uh, meter cube per day. Okay now, so the 0.8% is 0.8% is coming. So you can see that this much kg per day of I think there is one mistake. Huh. So here one thing which we have assumed that density is as one. Okay, now that's why you can see that we have converted this meter cube into kg. Okay, now here in the question it's not written that, but we have assumed. See, the flow rate is this much, 25 meter cube per day. We have multiplied by the solid concentration, that is zero point 0.8 into 100, then that will be around 20 meter cube per day. And as we are converting into uh, kg, then we are assuming the density as to be 1000 kg per 1000, which is not true because the density will be different. Okay, na, it should be around, density should be have been mentioned in the question. It will be around 1.1, because 1000 is the density of the water. Okay, now this is not density of the solid or sludge. Okay, now, so but for this question we have assumed that it is at 1, so that's why the solid is to 20 into 10, 20 into 1000, that is 20,000 kg per day. Okay, then required surface area, whatever the total solid, and what is the whatever this is the solid loading rate, then we have found out the surface area will be 400 meter square. Okay, now this much kg is coming, this much, and per day we know that this is the loading rate. Okay, now, like, for a particular batch, this much amount of solid is required per area. Okay, now, so total area will be total solid divided by solid loading rate, that is 400 meter square. Okay, now in question it has been written that we have to use two units. Okay, now the two units, for each unit the area will be 200 meter square per thickener. And we know that the diameter of the each thickener is, diameter can be as it is circular, then we know the area is equal to 4 pi d, 4 pi d square. Okay, no, sorry. Pi r square is the area of circular thing. Okay, now if we convert into diameter, then it will be pi d square by 4. Okay, now, so here you can see this is area. Then if we have to find the diameter, then this 4 will go on the area side. 4 into d divided by pi ka under root. Okay, now, so we have put the value, and then we have find out the area, diameter, that is 15.96 meter. Solution. Okay, so this was all about today. Do you want to look into more question, or if we have around 20 minutes, sorry, 15 minutes, if anyone want to discuss anything, then they can write in the chat box, or you can unmute yourself and you can say, or I have few question if you, but this. So if you see this thing I have taught in the last semester. Okay, anyone have any question? Try to answer the, no, I don't know, this thing has been not discussed to you. Can anyone answer this thing question? Increasing the solid content of the sludge through mechanical or gravity leads to, if we are increasing the solid content, what will happen? Anyone? B. Increase in the total volume of the sludge. How volume will increase if we are increasing the solid content? We have discussed few minutes ago that solid concentration is fixed. Solid concentration is fixed. Then if the solid content still is increasing, then at the see how solid content is defined. B concentration. See, I don't how see how it is defined. What is happening? This solid content is always defined by x by total volume. Okay, na total volume, and we know that the x is always fixed for our solid. Now imagine the overall this is increasing. If this is increasing, then this must decrease. So the correct answer will be C. Decrease in the total. Also, if just simply if we are using any kind of thickness, then overall the volume will decrease only. Are you getting my point? What I'm saying? Are you getting what I'm saying? I hope you have. If you are getting it, the correct answer will be B. This thing has not been discussed. Which of the following process organic matter converted into? Answer this question. In the process of anaerobic sludge digestion, organic matter is converted to D. Yes. A sludge digestion process usually leads to D by the correct answer. Yes, all new cell, CO2, methane, everything is produced. Sludge digestion process usually leads to less water content in the sludge, less total mass of solid in the sludge, higher total mass of the solid in the sludge. Digestion process done on a liquid. B is the correct answer. Less total mass of the solids in the sludge because organic matter is getting converted into CO2 and methane. So that's why what will happen that solid mass which was there is getting converted. Remember, don't confuse. In digestion, we are acting on the sludge solid, that is organic matter, but in thickener or when we are dewatering, then we are not changing anything to solid. These two processes are very different process. Do not get confused that there we are talking about solid, there we are not disturbing solid, there here we are disturbing solids. Just keep this thing aside. Okay, now this that will not. Last question. I think we will end the session here with this question. Sludge drying beds are one of the simplest method of dewatering, but they have large land footprint. Land footprint means they occupy very large area. Dewater sludge essentially have zero or near zero water content. Anyone? So this will be incorrect only. Okay, now dewatered have some what do I call some water content. a huge amount of water content. Okay, now only de-water only means like solid content generally what happened that increase from 6% to maybe maximum 20%. Okay, now so still it will have huge amount. So yes, correct answer is A. uh, Incorrect, you can see here we have seen this thing is also like see some of um, after conversion into methane also something is left, and the bioproduct can be used as a biofertilizer. Okay, now the product can be used as a biofertilizer. Identify the appropriate option for the use of wastewater sludge. D. Yes, D the correct answer. I think sludge can be bioenergy, that is methane. Then compost the after like whatever the complex organic matter was there, if after digestion some part will be get converted into methane and CO2, and some part will be left as a biofertilizer. This is also the ace from incinerated sludge can be used as raw material in construction such as production of brick, cement or concrete. Okay, now again these are some of the numerical. Okay, so that was all about today. So anyone have any doubt regarding this? I will take care of this assignment 5, question number 9. Apart from this, any another problem or any doubt? If not, then we will be ending this session. Please do join next week. That is on again on Tuesday. Tuesdays using same link. You will be notified one day before the session. And as always, I request everyone to please go through the lecture notes so that you can participate in the question answering session. Okay, so I if no one have any doubt, then we can end the session. Thank you for joining. Okay, then I am ending the session. Tata everyone. Good night.